Welcome back. In this video, I will take you through the process of identifying Lewis acid and bases. So those are the processes. So we start with Lewis acid. How do I identify it? Now, to identify Lewis acid, one of the ways to identify it is that when you see a molecule that has fewer than 8 electrons on the central atom, such molecule is a Lewis acid. And an example is boron trichloride and aluminium trichloride. So look here, e.g. aluminium trichloride LCl3 and boron trichloride. Now, why are they Lewis acid? Because they have fewer than 8 electrons on the central atom. Now, I will show you that now. That is, they are non-octet. Now, look at here. For example, let me use here as an example. Now, see, we have aluminium trichloride. So, if we draw the okay, now let's do it. Aluminium has 13 atomic number of 13. So 13. If we break it down into shell, k element shell, we have 2, 8, 3. Now this is the valence electron, 2, 8, 3. Now if we are to write the Lewis electron dot structure for aluminium, what we have is this Al. So we have 1, 2, 3. So now Cl3. Now Cl comes here. When Cl comes here, another Cl here to join with this electron, another Cl here. So now when they join together, this is what you have. This is what you have. So you will discover that there are no electrons here. There are no electrons here. So because of that, so that means the electrons are not up to 8. Now you see they are none of the molecule in which the central atom has fewer than 8 electrons. Now aluminium is the central atom here, so it's fewer than 8 electrons. So in that case, that means it's a Lewis acid. So the same goes for boron trichloride. Now for boron, the atomic number is 5. So for boron, so that's 5. So now for B, that's, if we break it into, that's 2 and 3. So now for B, the same way, dot here, then Cl. Boron is the central atom, so because there are no electron here, it's empty, not up to 8. So if we count with the one that chlorine will donate, so we can discover that this will make up 1, 2, 3, 4, 5, 6. So not up to 8. So that's the reason why that's one of the ways to discover a Lewis acid. So now another way to know which one is a Lewis acid is anyone you see that the molecule in which the central atom can still take more electrons, even though it already has an octet structure. So, but it can still admit more electrons. Then you know that that molecule is a Lewis. That is a Lewis acid. Now let me show you how. For example, PCl5 is an example. So, e.g., we have PCl5. We also have SF4. We also have SbCl3. Now, molecules in which the central atom can add additional pairs of electrons, even though it already has an octet structure. Now, how do you know such structure? Now, you know it with hybridization. Now, how do you do this? Now, for hybridization for PCl5 is I will show you the last. If you don't know much about hybridization by now, please go and watch our video on hybridization. So I did the hybridization of PCl5 there. So now look, I will just show you the last two, 3s to 3p3. So check the hybridization on that PCl5. Now look at it. These are our 3s orbital. These are 3p orbital. 3p. So now 3s 1, 2. So can you see 3s orbital is filled up already. Now 3p, so this one comes here, this one comes here, this one comes here. Now I'm taking you to the process of formation of PCl5. 1, 2, 3, 4, 5. Now this 3d orbital. So now PCl5, this is the configuration of phosphorus. So now for PCl5 to be formed, we have to promote one electron to the 3d orbital here. If we promote this electron here, so this is what we have. So when we have that PCl5 1, if we put one here, PCl5, that's Cl5. We put one here, another one here, 2, 3, 4, 5. Now you see, now molecules in which the central atom can add additional pairs of electrons, even though it already had an octet structure. Now you can see there are empty 3d orbitals here. There are empty 3d orbitals here. So because the d orbitals are not filled up, so we can say PCl5 is a Lewis acid. So that's the basis of that. Now let's go to the next one. Now ions with positive charge. Ions with positive charge are Lewis acid. Now an example is, for example, Al3 positive, H positive. An example, think of any ion with positive charge. So Cr3 positive, and so on. Which one again? Okay, those are ions with now Cu2 plus, for example. Now, how are they Lewis acid? Don't forget that Lewis acid are they accept electron. Now look at Cu2 plus, for example. Cu2 plus, so plus 2e negative. It has to accept electron for it to be neutral copper. That's this copper ion. So now you have Cu. So because it accepts it needs electron. It is electron deficient. So it needs electron. So as a result of that, is a Lewis acid. So that's that. Now that we have been able to identify that, I think we can move on to Lewis base. Now, when you're talking of Lewis base, you're talking of ions with unshared pairs of electron. Ions with unshared pairs of electron. So an example of such ion is OH negative, F negative, that's chloride ion. Which one can I cite again? Yes, phosphate ion, PO4 3 negative. Now these are examples of Lewis base. They have negative charge on them. These are examples of Lewis base. That's that Lewis base. So let me show you. Can I show you ions on charged pairs of electron? Okay. Look at OH negative. Let me use that as example. OH negative. Now oxygen is the central atom. Oxygen has 8 atomic number of 8. So that's 8 electron. We'll break that as 2, 6. So now let's write the electron dot for oxygen. 1, 2, 3, 4, 5. Let's put 6 here. So now if hydrogen comes here, this hydrogen here, it comes here. Now look at this electron here. If it comes here too, you can see that it has some shared pair of electrons that are not yet shared, that are empty. So ions with unshared pairs of electrons, you can see they are carrying negative charge. So they are Lewis base. So that's it. So another Lewis base, another one is neutral atoms with unshared pairs of electrons. An example is NH3 that we used in the previous example, and also H2O. Now let me use H2O for example. Now to use H2O for example, the same way I did, look at the electron dot for oxygen. 2, 3, 4, 5, 6. So now look at H here. Let this H come here. H is coming here. Another H here, making 2. Now look at these two pairs. They are unshared pairs of electrons. So anyone that has unchecked pair of electron will be a Lewis base. So that's all on identification of Lewis acid and bases. So you can see, look at this one. Anyone with positive charge is a Lewis acid, the negative charge is a Lewis base, and so on. So the structure of PCl5 I did here, if you don't understand it, you can go and watch the video on hybridization. Thanks for watching. Bye.